He is our security here at NETCB. Please welcome Hendrik de Bruin.
Excellent. Thank you, Keith. And thank you, everyone, for joining us this afternoon. Well, at the very least, it is where I am. Today, I will be talking about the OWASP Top 10, and more specifically, about OWASP and more specifically about the OWASP Top 10. As indicated there, my name is Hendrik de Bruin. Some of my credentials are also there, as well as my email address. Okay, let me just get back to my presentation quickly. Okay, so just some background about OWASP. So OWASP is basically the Open Worldwide Application Security Project. So they started back in 2001 as an online community that produces things like articles, methodologies, but also tools. So they have a variety of open source tools that you can utilize to assess your own web application security and so forth. So it really is a large community, and they contribute a lot to information security and so forth. In terms of the OWASP Top 10, so the OWASP Top 10 is basically the top 10 risks associated with modern day web applications. So the OWASP Top 10 was first published in 2003, and it was then updated again for the 7th time in 2021. And as I mentioned, it basically shows and talks about the most, the top 10 critical risks that's associated with web applications. So typically, the audience that should be involved with, the OWASP Top 10, etc., includes developers, so they understand, how the risks and threats and vulnerabilities are created within web applications. Architects, so they can adequately architect solutions, etc., within customers and within your own environments. Understanding how to securely architect environments. It's also important for CISOs, CIOs, and CTOs to have an understanding of the OWASP Top 10 and exactly how it features. And then lastly, security professionals. The OWASP Top 10 is essentially the fundamental piece of security assessment as it relates to web applications. So it is a great method for almost standardizing the risk levels, etc., associated with vulnerabilities. To give you an example, if you do a web application security assessment and you find something like a SQL injection vulnerability, it is often open to the interpretation of the security analyst to assign a risk associated with that. And that can often skew vulnerability assessments, etc., or penetration tests and the results associated with that. So the OWASP Top 10 really creates a standard to which security professionals can refer back to adequately identify, quantify these risks, etc. Okay, so just a brief explanation of the changes between 2017 and 2021. So firstly, the new first highest risk identified in 2021 is broken access control. So broken access control, used to be actually in the 5th place, but now it's moved up to the 1st position. Second one, cryptographic failures. So cryptographic failures actually used to be called sensitive data exposure, and it also moves up from 3rd place up to the 2nd place, and it's now called cryptographic failures, as I mentioned. So injection still remains the same in terms of the name, but it moved down from 1st place all the way down to 3rd. We also now have a new category called insecure design, which is in 4th. Then we have in 5th place security misconfigurations, which now also includes XML external entities, so XXE vulnerabilities, where you are able to perhaps inject malicious XML code into an XML environment. May result in something like code execution on the back end and so forth. So XXE or XML external entities is now included in security misconfigurations. We also then have vulnerable and outdated components. So it used to be called using components with known vulnerabilities. So they've changed that category, the name, and it's also moved up from the original 9th place up to 6th place. The next one there is identification and authentication failures, which used to be called broken authentication. As you can see, it moved from 2nd place all the way down to 7th place. We also have software and data integrity failures, which is also now a new category, which also includes insecure deserialization, which was a previous category. 9th, we've got security logging and monitoring failures, also previously called insufficient logging and monitoring. And another new entry for 2021 was SSRF, or server-side request forgery. So the next couple of slides will actually go into each one of these OWASP top 10 risk items, and it will give a bit more of an explanation as to what each one of them are. Where possible, I will actually show you how these vulnerabilities are actually exploited within a vulnerable application and so forth. Okay, so number 1, broken access control. So broken access control, in a summary, relates to being able to access functions or information within a web application that you should not have access to. So in principle, violation of the principle of least privilege. So the principle of least privilege basically means that a user or a system user or identity within the environment always needs to have as little rights or as little privileges as possible. And as soon as somebody can access additional information, it's a breach of that principle. So it includes things like being able to bypass access controls, ability to view, access, or edit people's accounts. IDOR specifically stands for Insecure Direct Object Reference. So perhaps being able to reference an administrative page by just manipulating something like the URL. Accessing an API with missing access control, browsing to authenticated pages as unauthenticated users, and also local file inclusion. Okay, so among all of these, they are all very relevant, but to me, the local file inclusion is, that's quite a serious one, and I will actually quickly show you what that looks like in real life. So let me move over to my vulnerable web application, and you can see it's basically got a host of vulnerabilities that I can now exploit. If I go to file inclusion, this is a typical example of broken access control. So if I were to click on one of these files, this is just to prove some sort of a functionality. So it says, hello, I'm logged in as admin and my IP address. But the most important part really is here at the top. So if you've taken a look at PHP pages, etc. in the past, especially if you've looked at them from a security perspective, you notice this is something that is used quite often to reference a page from within PHP and actually call that page. If you have not implemented things like hardening of the PHP service, etc., it is often possible to read files that's located on the server itself. Something like the etc password file, which is a file within Linux environments that contains all user IDs. It's also readable by most processors because most processors need to be able to understand what identities are located on that system. So this is a quick way to actually check when an application is vulnerable to something like a local file inclusion. In this case, you can see by just referencing that, it actually included all the user accounts contained within that etc password file. And I'm able to read that. Okay. So that's a typical example of a local file inclusion vulnerability, being able to read files on the server itself. Now, this also allows me to firstly understand which user accounts are located on the server, but I can also enumerate additional files. So things like the Apache server config and so forth and so forth. So, this is quite a a very severe threat and a severe vulnerability to have within your environment. Okay, next up is cryptographic failures. So in a nutshell, once again, any data being transmitted across the network or across the applications in clear text. Okay, so if you still have applications and sites, intranets, etc., within your environment that does not make use of things like HTTPS, and it makes use of HTTP or clear text LDAP passwords, etc., so port 389, etc., all of those items are considered cryptographic failures, and they are actually marked as critical findings nowadays. So other findings or other items that might also fall under the cryptographic failures category includes things like old or weak cryptographic algorithms. So when we do security assessments, etc., other than missing patches, this is probably the highest amount of findings that we do get within the environments, is weak or old cryptographic algorithms that's not considered safe anymore. Default or reused keys, invalid certificates in the certificate chain, so only having the actual certificate, web application certificate, without having the complete certificate chain all the way up to the certificate authority. Making use of deprecated or old hash functions like MD5, SHA-1, etc. Passwords being used as keys. And then also, as I mentioned, nowadays, if you find sites, etc., within the environment that only makes use of HTTP and no encryption, that is also deemed a critical finding. Okay, so the other one, which is a fun one to play with, is injection. So typically, this happens when input fields are not properly sanitized. So if you look at being able to supply information on a web form, etc., you need to sanitize the input that is that is inserted into those fields, because that might lead to things like SQL injection, etc., if you don't. So typical examples is not allowing things like semicolons, quotes, etc., to be input into fields where you perhaps just request something like a first name or a last name, because that's often not required. So alternative is also have pre-configured fields. So instead of allowing the individual to type something like Gauteng, allowed as an option to be selected. Okay, so, but in a nutshell, SQL injection or injection nowadays include things like SQL injection, cross-site scripting, as well as command injection. So what I will actually show you is some of those vulnerabilities. Let me switch back to my application. The first one I want to show you is SQL injection. So this again is just for demonstration purposes. In this case, I have a field here, user ID, and it's obviously requesting me to insert some sort of a user ID. So let me start by inserting one. Okay, I get a result. First name is admin, surname admin. Okay, let me check number 2. Okay, there's another username, Gordon Brown. There's another one, hack me, 4, etc., Pablo Picasso. Okay, so I can retrieve some information using the user ID, which is probably not a good idea to use in the first place, but this is just for demonstration purposes. What I typically do as a next step to test if these fields are potentially vulnerable to something like a SQL injection attack is to just insert some characters like semicolons, quotes, etc., and to submit that. Oh, okay. That's great. It comes back with an error. That tells me, firstly, that input field is not being sanitized. Okay. And how I know that is because it actually says here you have an error in your SQL syntax. So that tells me I have a correct direct interaction with the database using characters like semicolons, etc. And that also means if I correct the syntax, I might be able to retrieve additional information. The other item to highlight here is the fact that it exposes the fact that I'm using a MariaDB database, which is also a finding. And I'll get to that later on in the OWASP top 10. Because this is information that you don't need to give to an end user or somebody who inputs fields incorrectly. They don't need to know what database you have in the back end. Because now, once again, I now know how to fix my syntax. So let me go back. I'm going to fix this. I'm going to say 1, put in a quote, and I'm going to say or 1 equals 1, semicolon, and those little dashes at the end in SQL terms, that's how you comment the rest of the script. So let's submit that. And lo and behold, I get to retrieve all the accounts within the database. Now, this is just a simple example, but the same applies for the rest of the fields. So things like passwords, etc. And just by using that simple string, I managed to retrieve information I should not be able to retrieve. And this is a classic case of SQL injection. The next item I want to show you is cross-site scripting. So cross-site scripting allows you to basically exploit the vulnerability, which allows you to launch JavaScript on the browser end of the application. So what I'm going to do is to add a little script here. It should, if it works correctly, pop up an alert. Let's say net.Share 2023. Here's the closed quotes. Let me close the bracket. And let me close the script tag. Let's see what happens. I'm just going to copy that in case there's an issue and I have to retype it. Oh, okay. So by submitting that, it came up with an alert or a pop-up in my browser. Okay. And you can see there it says net.Share 2023. Now, this might not look like something that could cause damage on your end or be able to exploit it much. But in reality, what this proves is that I am able to execute commands in JavaScript on the browser side. Once I can do that, it means I can also start to intercept things like cookies. So if you have existing open browser sessions and you have existing authenticated sessions to applications, etc., most of them work by making use of cookies, etc., for security and session IDs, etc. Once I can steal that using something like cross-site scripting, that means I have your cookies and I can authenticate as your account to those different applications, etc. Something else while I am on this is actually the fact that you can see here there's a security setting set to low. That I can also manipulate to have an effect on the site. Okay, and in terms of injection, the last one I want to show you is command injection. Okay, so we often find on applications, once again, where it allows you to run certain commands, often on monitoring applications, etc., and might ask something like that, ping a device to check if it's active. So what we can do here is let me ping my local gateway and see what happens. Okay, so I input my IP address and it comes back and it says, great, it can ping my local gateway. But perhaps I can manipulate this to do something else. So I'm going to escape that or break out of the normal ping command with the IP address. I'm going to add some content to the back. So if you are familiar with Linux, you know the ID command, which will display which user you are authenticated as or which account the application is actually running with. Let's see what happens if we submit that. Okay, it comes back and it shows me my user ID. So let's play around with this a little bit further. I'm going to add that and let's see what else we can do. Let's say if we can read the etc parswd file. Submit. And there we go. That means I now have remote code execution on that server itself. I can do multiple things, whatever that www-data account is authorized to do, I will be able to do with that account. So I can also check the IP address, things like that. Um, there's our IP address. And ultimately, if I have sufficient tools on the device, I can perhaps use something like wget to download a additional PHP file that allows for remote code execution. Alternatively, I can perhaps even use bash to make a remote to actually execute a remote shell to my listener on my side as well. Okay, so back to my slides. The next one, insecure design. So insecure design is quite a large topic, and it's got a variety of interpretations. But the way I like to always remember this is where a configuration item creates the vulnerability and you aren't necessarily able to resolve that. So a typical case may be a system or an application, or let me be more specific, a component of the application that might use something like containing a clear text password in the configuration file. That's a problem because somebody who's got access to the device can read that file, retrieve the password, use it for their own nefarious reasons. And it doesn't help if you just encrypt that field, because then the application won't be able to correctly interpret the password. It will just use that hash. So that's a typical example of insecure design. If you look at the image that I have here, this is another example where you've got different components of the application. You've got the application, which is the front end. In the back, you've got an API that perhaps talks to something like a database. If this API is not secure and it allows an attacker to inject additional content or information into this API, it might have a negative effect on the application or the database, insert additional users, whatever the case may be. The fact that you have this ability, this unsecured portion in the entire application, that identifies as something that we term insecure design. Okay. Security misconfigurations. So these typically include things like missing appropriate hardening. Okay. So as I mentioned previously, even though that previous slide refers to an insecure design, that also applies to this, which is a missing appropriate security hardening. That API should have been secured. Also, when unnecessary features are enabled or installed, okay, the specific vulnerability or setting within PHP that led to that local file inclusion, it's a specific setting that you can enable or disable, as an example. That feature should be disabled because that's a security feature. Okay. Also, security features disabled. So if you have something like Windows Defender on a server, etc., and you purposefully disable that function, something like a local firewall on one of your application servers, disabling the firewall, all of those type of findings, default credentials. Error messages reveal sensitive information. There's my example from previous. The MariaDB server, we should not know that, and it's no reason for us as end users to see that in some sort of an error. So that would also entail a typical security misconfiguration vulnerability. Okay, vulnerable and outdated components. So a lot of applications nowadays make use of a lot of different plugins and components and packages, etc. A typical example would be Log4j. Whether you are using open source components, Apache, Tomcat, etc., or whether you are using Microsoft proprietary technology, they were all affected by the Log4j vulnerability. And even today, that vulnerability or that component with the vulnerability still exists in a lot of systems. So that's a typical example of vulnerable and outdated components. So having a component that you know is vulnerable as part of your overall application. Also, outdated components. So if you have all the latest Tomcats and Apaches and application servers, etc., but you're still using a MS SQL 2016 database running on a Windows 2008 server, that is a vulnerability, and that will be categorized under vulnerable and outdated components. Also, things like upgraded components not happening timelessly, etc. Just as a matter of interest, I've included some screenshots from our security and compliance solution, because that's typically how that solution can assist you in remediating these findings, because our security and compliance solution will automatically be able to detect on your applications, on your servers, if there are components with known vulnerabilities associated with them. Identification and authentication failures. So essentially, the easiest way to describe this is where the fields that require usernames and password or authentication or identification is not making use of things like multi-factor authentication, or displays messages that allows you to enumerate further information. So WordPress is famous for this, because WordPress has this wonderful feature where if you type in your username or password, or even if you type in an incorrect username, it will actually tell you that you have typed in an incorrect username. That's terrible from a security perspective. You don't need to give that information. You can say it's an incorrect username or password, or both. But you should not allow the system to tell the individual that he's making use of an incorrect username. If you then in WordPress supply the correct username, something like administrator or admin, typically it will also tell you the password you entered for username is incorrect. Okay. So that once again opens up the gateway to do things like credential stuffing and brute force, because now just doing some basic checks allows me to identify the username. Now that I've got the username, it's very simple for me to start doing brute force attacks. WordPress is also terrible when it comes to that, because natively it also allows you to do things like brute force attacks. And a lot of web applications does not adhere to strict authentication mechanisms, policies, etc. So a lot of them allow you to indefinitely try and log in with an account without at some point locking it as an intruder lockout. Okay, so some of the other findings that relate to this: weak or default known passwords. These are often found in IoT devices such as printers, etc., webcams, and so forth. But also a lot of the times in Tomcat and databases. Plain text or weakly hashed passwords, missing or ineffective MFA. Yesterday, during the technology showcase, we also briefly spoke about multi-factor authentication. If you don't have multi-factor authentication on your applications, it is also a finding according to OWASP. And as I mentioned earlier, OWASP Top 10 is essentially considered the de facto standard for web application pen testing, etc. Exposes reusable session IDs. You'll often find that when you log on to PHP applications, as an example, it's got a session ID. Sometimes that session ID is something simple like 1, 2, 3, etc. So it's easy to manipulate the URL or the cookie and then gain access to another session. So it is important to have those session IDs as randomized as possible, not using something like one every second, because also that is easily reversible. So having strong session IDs to avoid having them being reused, etc. Okay. So software and data integrity failures. So the most important part really that differentiates this from insecure design is this item called across the pipeline. So as I mentioned earlier, modern day applications are not a single instance anymore. You have multiple components, things like databases, APIs, plugins that's downloaded, etc., etc. And it's important to have all of those components checked and ensured that they are not susceptible to vulnerabilities. So once again, I mentioned the log4j component. That's a component that forms part of a bigger application. If that portion is vulnerable, it might affect the entire application. So that's specifically where things like software and data integrity failures come in. So if you make use of plugins and components in your application pipeline, that comes from different vendors or perhaps open source communities, etc., it's critical to ensure that they are up to date, and that you pay adequate attention, that there's no vulnerabilities residing in any of those components. Security, logging, and monitoring failures. Okay, so a lot of environments, they make use of the application servers and databases, etc., but there's no centralized logging environment. So if something happens and somebody attacks your Apache web server, it's difficult to chain and relate that to other attacks within the environment. And that's why it's important to have something like a SIEM solution where your web application logs, your firewall logs, your server logs, etc., all contained into one system. And it's easy to then contextualize threats and so forth. But also it's much simpler to find specific issues or threats related to that application. So this is something we find quite often, where the application will just log the data to a file if we're that lucky. There's also no centralized retention of those log files, etc. So all of those things play a role. And also, once again, I included some screenshots here from our own security and compliance solution, which will assist you to actually comply with this, where we can ingest logs from your various web applications, your servers, etc. Centralized log management, etc. And then also the last item on the OWASP top 10 is server-side request forgery. So server-side request forgery is basically the ability to enumerate or interact with applications within your DMZ or within your firewall through an application that's exposed on the firewall. Okay, so if you look at this picture over here, we have the firewall, and the firewall allows us to access an application through port 80, which is a finding. We mentioned this earlier, HTTP. But also through port 443, which is HTTPS. Okay. So the firewall allows the individual to interact with this application through those ports. It does not allow the user to interact with applications on the inside of the network, within the DMZ or behind the firewall. There's no rule in this picture specifically that allows us to interact with these applications. But a server-side request forgery vulnerability will allow us to interact with this application, and through this application perhaps do something like API calls or HTTP calls, etc., to these applications, allowing me to further enumerate with what's happening within the environment. Okay. So as I mentioned, this is a new entry from 2021. So it's obviously it's been proliferating a lot, especially with the use of cloud services and so forth. As far as I am aware, the Q&A is open. So if you have any questions, feel free to pop it in the Q&A, and I believe the chat is also open. So if there is anybody who wants to ask something, you are more than welcome to. Doesn't seem like there's any questions. In that case, thank you very much for your time, and I hope you enjoy the rest of the conference. Thank you.